Today we are going to discuss about bcs405b graph theory module wise important questions. Module 1 graph basics. First question, define a graph and explain types of graphs. Second question, prove the number of vertices of odd degree in a graph is always even. Third question, define isomorphic graphs and check if given graphs are isomorphic. Uh, Fourth question, explain walk, path, circuit with example. Fifth question, bipartite graph, subgraph, walk and path. Sixth question, prove a simple graph with n vertices and k components as the most n minus k into n minus k plus 1 divided by 2 edges. Next, module 2 Eulerian and Hamiltonian graphs. First question, state and prove the necessary conditions for a graph to be Eulerian. Second question, define Hamiltonian path and circuit with example. Next, draw Euler and unicursal graphs. Fourth question, prove Eulerian trial exists if exactly two vertices have odd degree. Fifth question, traveling salesman problem using graphs. Sixth question, in a digraph we have to prove that sum of in degrees, sum of out degrees equal to number of edges. Next, third module, trees and connectivity. First question, define tree and prove that one and only one path exists between every pair of vertices. Second question, prove every circuit has even number of edges in common with cut set. Third one question, find and construct binary trees height and properties. Fourth topic, show that tree with n vertices has n minus 1 edges. About these topics only related problems you have to do. Next, fifth question, prove that distance between two spanning trees in a metric. Prove vertex connectivity, edge connectivity and minimum vertex degree. Next, fourth module, define planar and non-planar graphs and state Kuratowski's theorem. Next, second, prove Euler's formula v minus e plus r equal to 2. Next, third question, give planarity conditions. Next, fourth, write adjacency and incidence matrices for a graph. Fifth question, explain the circuit matrix and path matrix. Fifth question. Next, sixth question, explain relationship between planar graph and its dual. Module 5, coloring and matching. Prove that every tree with two vertices is two chromatic. Next, define chromatic polynomial and find it for a graph. Third question, state and prove 4 color and 5 color theorems. Fourth question, explain greedy coloring algorithm. Fifth question, define and illustrate complete matching minimal covering. Next, sixth question, we have to prove that n vertex graph is tree if chromatic polynomial is lambda of lambda minus 1 to the power of n minus 1. Thank you.